This video looks at the case of three planes with no common intersection. Now we've given three equations. Part A, show the system of equations has no solution. So we're told it has no solution, and give a geometric interpretation of these equations. So first of all, we need to solve the three simultaneous equations. You know how to do that using Gaussian elimination. Pause the video, have a go yourself. So let's start with the bottom element. Let's go row 3 minus row 2. 1 minus 1, 0. 5 take negative 1 is 5 plus 1 is 6. Negative 5 take 1 is negative 6. 2 take 3 is negative 1. Got row 2. I can go row 2 minus a half of row 1. I could have done these two steps in one. Depends on how comfortable you are doing them in one go, but I could have done that. 1 minus a half of 2 is 1 minus 1, which is 0. Negative a half minus a half is negative 1.5, which is negative 3 over 2. 1 minus negative a half is 1 plus a half. 1.5 is 3 over 2. 3 minus a half is 2.5, which is 5 over 2. Now, to make my life easier, I look at all those fractions and think they're awful. So I'm going to go row 2 times by 2. And get rid of them all. So I have 0, negative 3, 3, and 5. And my last step is to get this 6 to be 0. So I'm going to go row 3 plus 2 lots of row 2. So 0 minus 0. 6 take negative 3 times 2 is 6 take 6, which is 0. Negative 6 take 2 lots of 3 is negative 6 plus 6, which is 0. Negative 1 plus 2 lots of 5 is negative 1 plus 10, which is 9. And here we have a problem with this 0, 0, 0, 9. That's saying that 0 equals 9, which is not true. So this is telling us there's no solution. So part A, the final row corresponds to the equation 0x plus 0y plus 0z equals 9. Now there are no values of x, y, z that satisfy this equation since 0 can't equal 9. So therefore the system of equations has no solution. Part B, give a geometric interpretation of these equations. The equations represent three planes that do not have a common intersection. We also know the planes aren't parallel. Now, three planes with no common intersection can also be the same plane. So a system of linear equations in three variables can represent multiple copies of the same plane. If we look at these two equations here, you can see if I label this equation 1, equation 2 is equation 1 times by 2. So there's a 1 in front of the x in our first equation. 1 times by 2 is 2. For our coefficient of y, 2 times by 2 is 4. And for our coefficient of z, 4 times by 2 is 8. So these two planes coincide. And the solution is a set of all points on the plane. Now we need to use two parameters. A possible form of solution would be if we let x equal lambda, y could equal mu, so z would be a quarter, 1 minus lambda minus 2 mu. Now lambda has to be an element of the reals and so does mu.